Okay, hi. Welcome to the second of three presentations on Introduction to XPath. In this video, our colleague Christopher is going to talk about the concepts and basic syntax of XPath. Take it away, Chris.
Thank you, Gabby. Yes, let's get into some concepts and syntax in order to write and think about some XPath. One of the first concepts that we need to cover that's really important is the context node. And that just happens to be whatever the current node is that you're interested in or where your search is taking you. So as you traverse further into an XML tree, you'll have fewer options available to your current context node. Hopefully that'll make more sense in a moment when I show you an example. But you might also be wondering at this point, what is a node exactly? Some of you might already know this from an intro to XML, but just as a review, a node is any element, name, any attribute, name and value, and any text string. But the important thing for us is that all documents start with a root node, and that is something in angle brackets, and it's the only node without a parent. Strings, on the other hand, are sequences of characters within element names. They're strictly nodes, but they are distinct from elements because they're just plain text and sequences of characters. And a string is expressed in quotation marks in XPath, whereas elements are not expressed in quotation marks and attributes are expressed with the @ sign. Atomic values are also important. They're value data types that are not nodes. So they're not names of particular things defined in the XML, but they're rather data types defined by the XML schema. So here are just a few simple examples. XS string indicates a string, XS integer indicates a number, there's a date, there's also decimal and Boolean value for true or false. So that's what atomic values look like when you're dealing with XPath. In general, I think it's good to think of XML context as a node on a tree rather than thinking of a stream of characters with angle brackets or tags. And some users do find the tag perspective helpful when we're thinking about document hierarchy, but it's also worth pointing out that an XML document is strictly a plain text document, so it is basically a collection of strings in a sense, but the logic and the parsing of an XML document makes it important so that you can distinguish between elements, attributes, and text strings, which is why XPath is important because it can help us really make fine-grained distinctions between those things when we're searching for content. Now, to illustrate this point, I'll just show you a really simple example of a poem text, which is rendered here as a tree. So we have an LG element, line group element with nested L elements, and the L elements have text strings, but you'll see also that there's a Q element for a quote that contains the text string of a quote. So you can see the hierarchy here rendered as a tree. In this slide, you can see how it appears in markup. So it looks more like a nested kind of hierarchical setup here in the markup where the LG contains L's and one of the L's contains a Q. And you can see how it appears in the text, which is all just, visually implicit to you. But the point is that as we're traveling through the XML document, as it were, if we're thinking of it as a tree, we're thinking in terms of a kind of familial relations. So in this case, the parent node, the root node for this simple illustration is the LG element. And the LG has two child elements, namely the two L elements. And the first L element has another child element, which is a Q. And the Q element has text strings, which are essentially siblings. The two L's are sibling elements, and the Q has two descendant elements, namely L and LG. So again, we're just kind of thinking about XML trees as kind of family tree structures, and that helps us navigate our way through the document when we're doing XPath searches. So on the highest level, we're looking at XPath as a kind of location path language, and that results in a node set. And these paths can be expressed in our searches as either absolute or relative. So here's an absolute path example. The absolute path starts with a single slash. And what that says is take me to the root element. And then following that is what comes after the root element, what's contained within the root element. So in this case, we just have a div. And then another slash says take me to any first nested div within that first div. And then take me to a head, which is nested within that second div. Now, a relative path uses the double slash, and the double slash says take me to any element anywhere in the document. And in this case, we just have an example where we're taking you to any L element. So double slash L says take me to any L element. And then the single slashes followed by the two dots says now go up in the tree from the L element until we reach div. Now, the syntax in XPath is generally formalized in this way, with an axis name, double colon, node test with a predicate in brackets. Now, what that means, practically speaking, is illustrated here by this example. So double slash LG followed by single slash L is a relative path that says take me to any LG element followed by an L element. Now, that syntax can be formalized as what I just said, axis name and node test. And in this case, you could render the same relative expression as L with a predicate parent double colon LG. So find me any L that has a parent LG element. And you can also nest predicates. You can do multiple functions in XPath. So in this case, we have a relative path that says take me to any speech element, SP, that contains the uppercase string Hamlet within its head. Now, I've mentioned axes already in the formal model of XPath expressions, and this just gives you a full list of all of the XPath axes that we tend to use. And I'm not going to review them all here, but this is just to show you for reviewing purposes how you can navigate through the tree. The fact is, a lot of you won't ever need to use these XPath axes in your XPath expressions. Sometimes you will need to use them. I've only used them rarely myself, but it's good to know in the sense that you can understand how the elements relate to each other. And also, as in the first case with the child axis expression, you can usually express that kind of axis with a simple single slash, or in the second example, with a double slash. So there are kind of shorthand ways of doing axis expressions. But the important thing is to know where you are in the tree. Now, in terms of general usage, most of us have to use XPath in this very basic way, which is create a location path with a single slash or a double slash. So with an absolute path or a relative path. And this allows you to traverse the XML tree to identify nodes. The predicate is always contained within brackets, which allows you to filter the results of path expressions. The dot is the context node, and that's where you are in the document path. The axis is indicated by the double colons, and this allows you to go into a certain direction within the tree. And then finally, there's the function, and this allows you to perform additional actions on the information that is retrieved or received in the XPath expression. Most of the time, this will be a function like count for counting things. But in this way, you can also see that XPath can be used as kind of quasi-programming language. So in this case, you can create a variable using a $sign. And you can even do things like create for loops. So here, you've got an example where you get the first and second SP attribute values auto-generated in a for loop. Now, there are 4 kinds generally of XPath searches, and I just want to review these because it'll give you a sense of the ways that we use XPath and how we write the XPath. So a path expression, return the location of nodes in a tree. So for example, if we want to find all the L elements within quatrains, so LG type equals quatrain, so we do this /LG, which says take me to all the LG elements that have the type value quatrain. So if you have, couplets as another type attribute value, you'll ignore those. You're just looking at quatrains and return the L elements within those quatrains. Here you're going to all L elements, so /L, all L elements that contain Bibble elements within note elements. So basically, if you have a note element in an L and it has bibliographic data in it, you want to retrieve that using this XPath expression. So that's a location kind of search. With the axis I just mentioned, this is something that you might not often use, but this will show you the kind of equivalence of an x-axis expression rendered in 2 different ways. So find all the descendants of the current element that are heads. Could be written with the context node dot followed by a slash with descendant :head, or you could simply just use /head. Similarly, if you want to find the parent element of anything that is an L, you can do it in this way using /LG/L, or the first example of a pure kind of axis expression. Now, predicates, this is again filtering. Suppose you want to find the first L within each LG. Here you can see that the number 1 is rendered in brackets after the L, and that just means find the first thing, and in this case the thing is the L. You can also use the last predicate. So if you want to find only the last paragraph in every second level div, for example, you can see this path expression that shows you in the brackets the last argument followed by open paren. So it's just find the last bit of text string within the P. Now, for an example of functions, so if you want to do something with the information, suppose you want to count all the LG elements. So you're not returning the value, but you're just counting how many things there are. So that would just be /LG with the predicate of count followed by the dot, which means count the number within the context node, which in this case is the LG. You can also use string length to get kind of length calculations. So if you want to, find out whatever the string length is of the content of the LG element, you can use that as well. Or you can count the div elements that have P that only have 1 paragraph. So you can see here the EQ sign is used to mean equal. So you can use greater than or equal to in this case, or less than in XPath expressions as well. So there are various kinds of mathematical calculations that you can include in addition to simply searching for things. Now, I just want to review very quickly what we've just learned about XPath syntax. We've got the path step, which takes you from the root node out deep into the XML document. We've got the descendant axis, which allows you to go anywhere in the document. We've got the attribute axis, which allows us to identify particular attributes and their values. We've got predicates, which are rendered within square brackets. We've got the dot for the context node, and here you can see a greater than mathematical calculation, GT. Got the parent element, which is just 2 dots, so taking a step back up in the path, as in this case. We've got the wildcard borrowed from regular expressions, which basically means anything. So if you want some flexibility in your search, you can use the wildcard. Similarly, you can use the wildcard on attributes. So if you want some flexibility as to searching for different kinds of attributes or attribute values, you can use the wildcard for that. And then finally, the function, which allows you to do kinds of programs on the search. So having done that, I think it would be important for you just to see how this looks if we're in Oxygen, for example. So here is a TEI document that is a rather complicated one. And it's a genetic text, so it has lots of information about revisions. So for example, if I'm interested in revisions and I want to search for all of the add tags, and because I'm using a relative path here with the double slash, I'm saying find me any add tag anywhere, including add tags that are nested within ads. So a pretty generous search. We then get a description that has the content of that node, but we also have this XPath location here, which is really important because it also allows you to see exactly where you have traveled in the XML document to arrive at the context node, to arrive at your search results, okay? This is really important to pay attention to because it allows you to see where you are in the document, and it can sometimes help you troubleshoot any problems you might be having with your XPath searching. So if I want to add a predicate, you'll see here that Oxygen very kindly offers me a list and a drop-down menu of all of the attributes in this document. So I don't even have to type it. I can use, for example, place and then add an equal sign. And suppose I'm looking for all superlinear additions. I can now find a very specific type of addition. And this might be interesting from a genetic perspective. Now, suppose I also want to find out how many add tags have deletion tags as parent elements. So here I've added a deletion. So now we're looking at how many add tags have a place value equals above that have deletion parents. And there you can see that sort of information can be fairly interesting if you're looking in, as in my case, at certain genetic information in a document. So this is how it works in Oxygen. It's a kind of iterative and experimental process, but as you can see, you can find some pretty interesting information. So having just done that, I think I'm done for this presentation, but Gabby, if you have any questions or comments, please jump in.
No, the only thing I'd suggest is to those of you who've just watched this, XPath is quite complex, especially some of these axes and things like that we've talked about, and predicates that might not, the difference between a path and a predicate and those sorts of things can sometimes be a little bit fiddly to figure out. I really suggest you go and find an XML file. You probably have some XML files of your own, or you can find some elsewhere. We probably made some available on the program of whatever workshop you're viewing this as part of. Open it up in Oxygen or some other tool that has an XPath feature like this, and try what Christopher's just done. Put in some XPaths in there, try and figure out what you think it's going to find and see if it matches. See if you can figure out the XPath to find certain kinds of context. Really just playing with this and seeing what results you get and seeing whether they're what you expect is really the only way to get comfortable with this. So I strongly suggest you do some exercises on that. I think that would be really useful.
It's the best way to learn. I agree.
Cool. Great. Thank you, Christopher.
Thanks.